Okay, so my name is Iwan Pribadi. I'm based in Jakarta, Indonesia. So I've been with the company for, this year is my 17th year with the company. So I've been with the company for a while. My background is civil engineering, and I got my master in construction management. So presently, I'm the global director for the construction. And this year, I was just been added responsibility to also being the global director for the plant business in Bentley. So anyhow, without further ado, so thank you for all for joining my session. So in this session, I will share with you our experience working with different users globally, how they use our system or technology to help improve their construction process. So we're going to focus more on the 4D and 5D aspect of it, and we're going to use many of our examples using our synchro technology. So we've gone a long way from, having projects using CAD, and then CAD, maybe this was in the 80s, and CAD 80 to 90s, and then the CAD moving into BIM. So this is what people always think about 3D model is BIM, right? But nowadays, we are now in the digital twin era. Okay, so what is digital twin? So the key differences between the digital twin than what say BIM before, in digital twin, you are actually creating an evergreen project representation digitally. So it is no longer a 3D model living in a space in silo, but you are actually connecting that model into real-time data. For example, you place it on the map geographically, and you are actually creating this model live by feeding different information using, drones, using mobile devices, using GPS, and so on and so forth. So your model is actually a live construction model that you will use to manage your project. So essentially what you are doing is to basically bridge the gap between the physical and the virtual world. The aim is to allow the project to maintain the virtual entity to coexist with the physical entity simultaneously. We believe that, like Jakub has presented earlier in the F1 formula, and then the engine manufacturers, this allowed the infrastructure's owner and contractor to deliver the insight in real time that will help the project in the decision-making process. So if you clone your project as you are doing it, you have more insight information that you can share among your project team to benefit from it. So how do we do this within our technology? So let's go into and deep dive into our 4D and 5D construction solutions. There are many different versions on what is 4D or 5D planning. But to us, the key ingredients in delivering 4D and 5D construction workflow starts with the three ingredients, which is the model, the schedule, and the resources. If you look back and look at all the contractors or the project, they always have these three ingredients, but somewhat they may be disconnected. Okay. Now, the key to produce a good and reliable 4D model, it requires that your model be a constructible model. You can imagine you cannot really schedule anything if you try to construct 10 kilometers of road, for example, and you only have one design section of that road. You need to be able to break it down into section of core, different component of the elevation of what you're trying to construct, and so on and so forth. So that's what I meant by the constructible model. Then you would use the same 4D model and connect the other field data. For example, because your model is not going to be just sitting in the office and for someone to play back, right? But you would like to actually collect your progress, capture issues in the field, sending RFI, record safety and quality incident in the field, and many different things that you would do, and try and able to connect those information back to your 4D model, then produce the insight reporting to make sure that the project is checked all the time. Okay. So this is basically the essence of 4D planning. The first and foremost, how do we get started? So this is always the confusion. Do I start with the schedule? Do I start with 3D model? Well, 3D model is given. When you move into construction stage, your 3D model is available. Your schedule may be at high level, but a good and proper 4D and 5D project will have to start with a good quantity. Many of the projects will have the estimate of the project from the get-go. But when the design is issued, there will be variation in how much you had in the estimate originally and how much that you have after the design is completed, right? So there are many different tools in the market to allow you to perform quantity takeoff and estimate digitally. Now, the key here is why we want to keep this within the same environment is so that the estimate or the takeoff quantity that you perform within our technology will be shared across in our planning tool and different parts of the system that we have. Now, what you produce essentially when you actually doing a quantity takeoff, you produce the quantity and the breakdown of the man hours or quantity into work steps, which is essential for your planning and your progressing purposes down the road. Once you have an accurate quantity, you may now produce your reliable 4D planning. Many people think that 4D planning is about connecting schedule and the 3D model together to create 4D playback. But in reality, 4D planning is a lot more than that, right? You're not only just creating a pretty pictures, how you would construct and sequence your work, but also 4D planning allow you to plan your work that I will go through furthermore in the next few slides. How would you take advantage and use it? But, one of the big example of the benefits in 4D planning, you can actually now see your plan visually. You can see there, you can detect, bad logics, and you can create safer side operation. By doing so, you would basically now able to take control of time and your budget 24/7. So you can perform this very easily in the project. While many users are happy with this process alone, so they think that, well, I got my 4D planning done after I connect my schedule. But other users are now, taking, the planning process further into more detail. So I'll show you the next few slides how they use this in the operation even more. One of the most popular work process is basically, the work packaging. All users start to adopt work packaging, which is basically adding more stuff during the short-range production planning creation to make sure that the plan that they will execute in the field is doable. So they're adding a process like constraint check within the 4D planning itself to basically check the material, check whether the drawings are available, whether you have resources to do the work and the equipment to do that, right? So from identification of, if you're just doing traditional 4D planning, you identify your look ahead planning as what should I do for the next 4 weeks. Now, among that pool of activities that you try to do, you would start checking whether those activities are really viable for you to actually can deliver in the field, right? So this process is quite important and now gaining popularity among our users. So how do we address this? There are two-step process to do this part. So first is the creation of job cards, or some people call it a work package. So this basically is nothing more than the collection of the model components. And basically you're gonna collect this and put them in a virtual container called the work package. So everything can be packaged early enough in advance so that you can understand what is the logical sequential work for you to basically execute this area. Now, the next step in this process is overlaying basically with the constraint check I described earlier, right? This is all about the short-range production planning. While this work package by nature is a short-term installation sequencing, adding the constraint management piece on top of the work pack during the look-ahead planning process add huge value to the process itself. So now, not only you know what you would construct, but now you know for sure that what you are planning will work in the field. So that will improve your field productivity quite substantial. So in this example on the screen, you can see that we are using different color coding. So red means it's not, constraint is not checked. So you have something, you're going to have a problem when you try to, execute this in the field. But the green, on the other hand, is everything's clear, everything's good to go. So you have all the material you need, you have everything you need to execute your work. So what you do is you can start using the technology to, for example, filter all these critical path of your schedule. Then you can see color green and red during the critical, activity execution in the field. Then you can actually cherry pick which one that you want to move forward and which one you want to delay and replace. So this process needs to happen way early before you hit the ground. Okay. Now let's go to the field. So all we have discussed earlier are basically how you plan your work. Now, this slide will show you how you would actually execute your plan in the field. So managing your execution is about managing field issues. There's no project without issues, right? And we all know that. So how can you document what you find? For example, you find a design issues that you need to raise RFI to your engineers. Or you just simply find somebody not tying off when they are working elevation. That's a field safety issues. Sometimes you find material that's defective, that's quality issues. So all these issues need to be communicated back to the rest of the project team and also be managed, right? So what we do, we're trying to change, if you look at many years ago, this process is silo and disconnected. So you have to basically manually log issues on a piece of paper, submit it, everything is manual process. Now today, you can use digital technology like your iPad or iPhone to basically log this process digitally and then associate this thing back to the 4D model as you see in this example here. So you can see where they're at from that issue. So when you send it to engineers, they can immediately understand, okay, this is an issue of this column, of this wall, for example. And maybe this is something we can fix quickly. So this will improve and streamline communication between field and offices and vice versa. And I hope you get this point here. Another use case where users like to do is to improve how you would operate in the field, right? So for example, in a planned world, permitting is very crucial for you to perform the job safer. Now, you can use our form technology to actually create and design the clever e-permitting system where you can actually show people whether the permit for the lifting exists for this operation or not. We also have capability to basically tag in that permitting system into an area so you understand what are the permit open and close, what's available in a specific area. We also have different tools like the measurement system here that allow you to measure distance, location, area on the spot using a tablet device like this. In the past, the model only showing, okay, this is how it looks. But if you try to really take dimension or things like that, you have to go back and call the engineers, for example, because many times construction don't have this tool at their disposal. There are also civil tools that allow you, when you're doing road building project, right? We have implemented different tools like station offset. You can create cross-section of the model element of your roads and then see the road profile and everything on a mobile device like this. So the hope here is that you have all of these tools to be able to perform your work efficiently in the field without you always going back and forth and trying to communicate this back to the engineer and ask questions, right? So everything is in your fingertips, basically. The next workflow, if you look at construction operation, is how you track your work completion. So there are two steps on this. First is basically what you see on the screen here is to capture the actual resource usage using timesheets. You can capture human resources by how many man hours you actually perform doing this operation, or you can also track equipment usage for a particular operation. So you can basically use, again, the tablet or iPhone to track, your resources use against your work packages, against your cost codes, or your WPS and your schedule. This is showing you basically how you could also use the technology to track and capture the unplanned activities. We know that unplanned activities cost contractors a lot of money and the project a lot of money. So if you are doing a site work operation, you go out there with the crane and a crew doing the work, and then you suddenly, I'm planning to get this done in a day or two, but you suddenly discover a big rock in the middle of the field that you have to deal with. So how do you capture this? So in digital technology allow you to basically take pictures, basically record the event, and then track the event costs using the timesheet or resource management tool to basically lock in the costs associated to an event that's unfortunate has to happen, right? So all of that will increase the project cost that you have to be able to recapture at the end of the project. So we have the tool that is appropriate for this, basically to make contractor and project easier to collect costs and share with the rest of the team. The second aspect of the progressing is about capturing what you earned, right? So if you're installing a piece of foundation, for example, you need to earn that foundation work in terms of quantity. Now, with the 4D technology, you don't really have to capture this progress collection manually using tabular type of form, but you can also use the model and basically color coding the model according to the progress that you make that day. The value of this color coding is huge because not only that is make you faster and easier because you can, weighted percentages of your progress based on the color code that you choose. You can also deliver this and just sync it back to the server, and the rest of the team would understand. If you look at this example in the corner here, right, you would understand what is installed, what is being staged, what is completed, right? So basically, if you have to submit this report based on the tabular basis, people don't essentially understand. But using color coding, you can rapidly, submit and make people understand of your progress quite immediate. Okay, so nowadays, as Jakub mentioned earlier, we also use different technology with the reality modeling. Now, not only, photogrammetry that we actually turn into a 3D model, but also now we now have a new technology. We join with different manufacturers to basically take photos and place it in the correct coordinate location and compare your plan against it. This brings huge value of how you can visually understand how your project not only being constructed, but you can see the reality, how that is being installed, like in this example, right? You can see that these towers being erected, and you can see on the side how you plan around it, right? By simply drag and drop, dragging left and right the red curtain here. So this one here is readily available within the technology stack that we have for construction. The last process in construction is how you would capture your digital inspection. This is the last step to allow you to do the digital handover at the end of your project. In this process, you would use similar to form technology to inspect your work. This is different inspection, as Jakub showed earlier, with the drone and then doing the bridge inspection use case. This is a bit different inspection than that. This one is more of a how complete you are with your progress, and you inspect doing QA QC check, doing quantity inspection. You can utilize this thing and basically making sure that what you install meet the required specification. And then to wrap all of this around, this is the last slide that I have. Basically, having all the information stored digitally within the connected environment that we have, you can actually create insight reporting that is holistic, very holistic, through a performance management dashboard. So this performance management dashboard is very crucial for the project to basically know the insight of the data into your data that you're collecting along the way. This allows the project to basically allow them to react faster to problems. And most of all, it will keep everyone on the same page at any time and anywhere. So this is all that I have this morning. Here's my contact. So please feel free to reach out to me for any questions that you may have.